Question 1, core 1, pie charts. Let's press pause. Let's try to construct this pie chart using this frequency table. Let's see how well you can do filling in the respective third column, the angles or the working out, and then using a protractor to get this down on this pie chart below. Press play when you're ready. Let's get down to finding the angles of all these 4 different hobbies over here by students. So let's start with this formula you need to memorize. This is not in the formula booklet. So the angle of one, let's say, row over here would be the frequency all over the total. Okay, total means you add this whole column together, number of students times 360. Okay, so that's something you need to really learn on this one before we even start this. There is another variation of that, but I think this is the best thing for this so far. So let's call this angle, or we can call it working out. Okay, so what we do is this. So 8, that's your frequency over your total. 8 plus 11 plus 4 plus 7, you get 30. This is non-calculator. You times it by 360. All right, now the trick is this. Now this is going to be over 1, and 99% of the time, this denominator 30 will be a factor of 360, okay? So basically what you can do is cancel these two things out. You can make it look like this: 8 over 1 times 12 over 1, okay? Because basically 30 times 12 is 360, if that makes sense. Okay, so this is 96 over here. All right, same concept with this one over here. So netball is the frequency, 11 over the total, 30 times 360. All right, now you may have gathered, obviously, that this will always be 12 when you cancel 30 and 360. So it's the same thing as saying 11 times 12, which is 132. Next one over here, it'll be 4 over 30 times 360. So this will be 4 times 12, 48. And the last one, 7 over 30 times 360. So this will be 7 times 1284. So notice how we got this magic number of 12 on each one of these. So if you find out the first row, which is 12, you don't have to do what we just did and do it for each one. You can just multiply it by 12 straight away, okay? It makes it much easier. So just do 11 times 12, 4 times 12, 7 times 12. That's the magic number, okay? These are your respective angles over here. So the first one, 96, 132, 48, 84. We're going to show you in a second how to plot this with a protractor. But first of all, just understand this key formula and how to work out this last column on angles. Let's get a protractor and let's show you how to represent these angles from your frequency table on a respective pie chart. So on your worksheet, on a circle, let's do this. So the first thing, football, let's represent 96 degrees. So let's get your protractor in this position and look at the outer rim, the black markings, and go to 96 degrees as you see with this red circle, or rather this yellow circle and red line over here. So 96 degrees would be roughly over here. Okay, now we're going to write football over here. We can't do it on the video itself. Put a black mark. We're going to put a black line over this red line over here and call this football. And that's 96 degrees. Very simple. Now let's move the protractor and we're going to start from where we ended up with. So this line, which is just drawn on the pie chart, is now going to serve as the starting point of netball. So let's position this new protractor over here. And let's go all the way 132 degrees all the way over here, so that we have this whole sector now representing netball, and you can write netball as well on your paper. Same thing, we're going to start where we ended up with. This line over here will be the starting point now of cricket, 48 degrees. So 48 degrees, let's do this over here, and we're going to end up with 48 approximately over here. So 48 degrees, again, this is going to be called cricket over here. And the last one, obviously you can see that this last one will represent tennis from here to here. That will be 84 degrees. If you want to test it, you can do that by moving the protractor again, and it will nicely end up in that way from here. From north to this should be 84 degrees anyway, and that's how you do it. So each of these red straight lines should have a black line on top of your circle, and you should have 4 sectors. The first one here, football, 96 degrees. Second one, netball, 132. Cricket, the third sector, over here, 48 degrees. And the last one, tennis, 84 degrees. Frequency polygons. Let's draw a frequency polygon graph for this frequency table over here. We have 2 columns on this as usual, And let's look at the key feature for this, which is a special word, which you'll come across in a second. Press play when you're ready. So the key word for this topic of frequency polygons is this word called mid-value. Okay, so the table below shows information about the heights of 40 primary school pupils, height and frequency. Okay, so first of all, frequency polygon means a mid-value. Let's type in, or let's write rather, midpoint over here. The midpoint between 1 and 1.05 or 1.025, the midpoint between 1.05 1.10 usually goes up in a fixed interval. So these are things you can check as well. All we do is this. So basically we go 1.025 across, or halfway between here, and 12 up. So that would give us a number of around here, or across. We'll do crosses for each one of these four things. Okay, 1.04, 1.075 across, 15 up, right the way up over here. This one over here, 1.125 across, and then 8 up. And then 1.175 across, and 5 up. We simply draw straight lines to show this. So straight lines from each point. 1, 2, 3. And there we go. That's your frequency polygon. Simple as that. So now let's get the chance to apply your knowledge and your understandings from your course style exam questions. You should have your written revision notes written and your toolkits all sets, and the 3 M's should seem a piece of cake, the mean, median, and mode for your frequency table. So let's get your notes together and let's try the best to apply them towards this question. Press play when you're ready. Again, let's press pause and let's attempt this continuous data frequency table, and let's try to find the mean and the median in parts A and B. Once you're done and use your cards, press play. Press pause, write parts A to E down if you have a printed worksheet already. Use this because you'll have graph paper already there, make it easier for you, and press play when you are ready. So this is a typical question on cumulative frequency. Let's read the question. The table below shows information about the heights of 80 students. 80 represents the total amount. Draw a cumulative frequency graph to represent this. So cumulative means keep adding from the frequency before. At a specific time, what is the frequency at that specific time? That's what it means, okay? The total frequency at that time should be say. So let's add a third column CF, which stands for cumulative frequency. First of all, let's see what this means. This means 8 students have a height of between 130 and 140. 11 students have a height between 140 and 150. Now, cumulative means you keep adding the frequencies from the row before that. It's a total amount of frequency at a specific time. So if we asked you how many students have a height of 140 or less, let's highlight 140 over here. It would be simply 8. So 8 students have a height of 140 or less. If we asked you how many students have a height of 150 or less, you would simply add 11 plus 8 over here. If you add those two together, we get 19. How many students have a height of 160 or less? Again, the same concept. It'll be 8 plus 11 plus 23. So this will give us an answer of 42. A quick way of doing this is to simply add 42 plus 32. 74. 74 plus 6, 80. It still means the same thing. So we have a good idea now of what these right-hand numbers mean. It's very important to understand the right-hand numbers over here. So the total here is 80. The total here is 80. These two should always be snap. N is another way of naming this total frequency column over here. Let's plot these numbers over here. So we're going to plot it like this. So if 8 pupils have a height of 140 or less, 140 across and 8 up on the cumulative frequency column, 140 across and 8 up over here. These are quite approximate, by the way, because we want to show you the general understanding of this topic rather than the nitty-gritty of the specific numbers. So it might be out by 1 or 2, but the key thing is to understand the how you do this topic. So this one over here, 150 across and 19 up. 150 here and 19 up. That means 19 pupils have a height of 150 or less. Right, 42 pupils have a height of 160 or less. So 160 across, 42 up. 170 across, 74 up. and 180 across and 80 up over here. Let's do a smooth curve from 0 to 0. Okay, there we go. Right, let's now do the 4 statistics from this graph. The first one is the median rather, and this will always be used as the first, let's say, point of call. So this is represented by n over 2 value. So in this case, it's 80 over 2, which is the 40th value. So the 40th value, we go across over here on the y-axis. There's always the y-axis over here on the cumulative frequency. We go across and we hit this over here, and we simply go down. Approximately, we're going to get an answer of this. This is the median over here. So the median, in this case, is approximately going to be 159, let's say. This is the median, 159. Perhaps we can say that over there. 159, there we go. So that means 50% of the data can be represented as people to have a height of 159 or less. 50% of people to have a height of 159 or less. Let's do the lower quartile. So that's the first one. We'll call it 1 over here because that's the first one we should do. 2 naturally comes from 1, i.e. the lower quartile. You have to halve this, 25% of the data, to write this in a more formal way. N over 4, a quarter of the data, would be 80 divided by 4, the 20th value. Same concept. We're going to go dividing by 4 over here. So if we do this, we get all the way across. It's a bit lower, that one, so we might be slightly off over here, but still it's the key understanding of this. So we would say this would be around, let's say 150. So 150 would be the lower quartile for this. So that means 25% of the data would represent people to have a height of 150 or less. Let's now do the next one, which is going to be the upper quartile. So the upper quartile is 3 n over 4. Call this number 2. We'll call this, and this number 3 will be 60 over here. 60th value, because 20 times 3. Let's go across over here. So if we go across again, the same concept. We times the lower quartile by 3. We go across over here. And we go down over here. This would give us the value of the upper quartile. So again, approximately this is going to be, let's write lower quartile. This is the lower quartile, that was 150. The upper quartile, this would be approximately, let's say 167. 167. 75% of the people to have a height of 167 or less. Interquartile range, part E, is the upper quartile. Let's call this number 3, by the way. Upper quartile, take away the lower quartile. So upper quartile, take away lower quartile. Now the upper quartile is 167 and the lower quartile is 150. This is where 50% of the data would lie. All the heights of the peoples would mainly lie between these two numbers over here. That would be 17. So 17 is the interquartile range for this, the 4th statistic, which is the upper quartile, take away the lower quartile. So looking back at this, it's extremely important you know how to plot the graph and to interpret the 4 statistics from this. We'll call this number 4 over there. So press pause, write this question down, parts A and B. If you have some graph paper, draw this histogram on that, and press play when you're ready. So the frequency table below shows the information of the heights of 30 students. So 30 represents the total frequency in this question, and we're dealing with different heights of group intervals over here, 120 to 160. Now these are called class intervals over here. So 120 to 130 is one class interval. And we always have 2 columns when we deal with histogram. So the height being one column, or the topic, and frequency being the second. That's how you recognize this. So there's a key word we need to learn over here called frequency density. And frequency density is actually what we use all the time when we associate this word with histograms. And this is defined as frequency over class width. This is not given in any formal booklet, so you have to understand this quite well. Okay, so let's highlight this over here. So how do we use this? Now, step 1, we're going to be using an additional column called frequency density. Now, frequency density you always have to create this third column called frequency density. It's defined as frequency over class width. If the frequency is 9, the class width is 10. 9 divided by 10 is 0.9. By the way, we don't include the 120 over here, so it's all numbers from 1 to 1 because of this sign, including 130, which is 10. 3 divided by 5, 0.6. 4 divided by 5, 0.8. And 14 divided by 20, 0.7. So we prefer to put these as decimals rather than a fraction. It's easier to write. Now, step 1, let's just write that down over here. So what we did, we just created a FD column, frequency density column. Step 2, that step 1 allows us or enables us to actually create a scale. They hardly give us a scale on these exam questions. So we can do this now by, that should be 120, by creating this on the y-axis a scale. So a range, the high is 0.9 over here. So if we go up in every 5 squares to represent, let's say 0.1, we can do a quick scale like this, if you can see this. Okay, and 1. FD is always your y-axis, by the way. So step 1 and step 2 pretty much defined over here. Let's do it. Now, basically, a histogram will always have continuous data on, the first column of the topic, and it'll be always a bar chart, and it will involve no gaps when you create this. So let's see what we mean. So the FD is 0.9 for the first row, and the range is between, on class interval rather, 120 to 130. So if we do a diagram like this, and we do a bar chart, we'll plot this as such, like this. Quite approximately, this is what it would look like. The next one, the height would be 0.6 between 130 and 135. So 0.6 is roughly over here. So if we go here, and the width is only 5 this time, so 5 would be roughly over here. The next one, again, we have a width of 5, and we have a height of 0.8 this time. So this really approximately, it'll be somewhere. Let's do this over here again. So it's somewhere over here like this, and it'll go as such. Last but not least, we have a height of 0.7 over here and a width of 20. So 0.7 is over here. So 0.7 and all across to 160 over here. This is approximate, by the way, but to give you a good idea of what we're talking about. Okay, so this is how a bar chart, or histogram should look like, rather, a bar chart with no gaps, and 2 steps. Okay, now part B, work out an estimate for the fraction of students, fraction over here, who have a height between 130 and 140 centimeters. So if we look back at the question, fraction, we could say a probability 130 to 140. So we want to look at these 2 class intervals over here. 3 and 4, we're concerned with this class interval and this one. So the total is 4 students have a height between 130 and 140. Altogether, if you look at the original question, 30 students altogether. So basically, it'll be 7 over 30. That would be a final answer for that one over there. So make sure you go through this, you understand it, but that's the key information for the Back to Basics question. Press pause, write this question down, part A. Press play when you are ready. So the histogram shows information about the time taken by athletes to complete a race. So 8 athletes, i.e. the frequency over here, again we're looking at the frequency, took 60 minutes or less to complete the race. Calculate the median. So this word, the median, is a new word in this context. You've seen it before, obviously, but the median, what does this mean over here? Now, let's first of all try to follow our 3 steps. So we need obviously to define frequency density, and to do that we need a scale over here. Now a scale we need to create, and to do that we need to understand again the 3rd step, which was the frequency formula. So the area of a block is the same thing as a frequency. Let's write that. Area of block is the frequency. Let's keep reminding ourselves that. So basically we're saying 8 athletes took 60 minutes or less. So 8 represents this number over here. So basically class width 10 times something gives us 8. 10 times what gives us 8? This will be 0.8. So I did that quite quickly, but you should be quite familiar with how this works now. So basically 0.8 is the height of this over here. Let's now do a scale. That's 0.8. We can see that this represents 1 over here. Over here, this can represent over here 2. This is 3, and so on. Okay, so that's quite nice. We have the whole scale already. We've got our scale. We've got our formula. Now let's try to find the median. Now the median is normally defined as, in a very basic terminology, n divided by 2, the middle number. Now let's try to create a frequency table over here. Let's create a table. Let's write this as time. Let's write this as frequency over here, because if you understand it like this, you're more likely to understand where we are heading, where we're coming from. So just really quickly, let's do this. Let's do this like this over here. Okay, so the time. Let's read off backwards now what we have over here. So time 0 to 60 minutes. Let's put 0 to let's say time, t for time, 60. The frequency is 8 over here. Let's say now we do the rest of it as well. T to 65, which is over here. How do we get this? This is quite self-explanatory now. So 5 is the width and the height is 2.4. 5 times 2.4 would give us 12. Okay, I'll write 12 over here. The next one we have is 65 to 70. So 65, and let's write over here. I'll put that there as well as 70. So this would be, obviously 5 is the width, and the height is 3.6. So 5 times 3.6 would give us 18. It's 18 over there. Now let's go to the next one over here. 70 to 80. So creating this frequency table would really help us. So it's 10 times something. 10 times 1.6 over here we have. 10 times 1.6 is 16. And the last one over here would be above 80. So basically T is, well, we can just write it like this if you want to. T is above 80. That would make sense. T above 80, and this would be over here 20 is the class width. The height is 0.3. 20 times 0.3 would give us simply 6. So now we can find the median from this, because this is what he used too. So from the bar chart, or the histogram rather, we created our frequency table. From the frequency table, we can find the median. Now the mean is a typical kind of question for this kind of scenario, but the median is quite rare in this situation. When it does come up, it is a harder topic. We can tackle it via methods of linear interpolation, which we'll try to do over here. But don't worry about that word. Just look and see the intuitive aspects of how we're going to do this. How many people are there all over in this race? 8 plus 12 plus 18 plus 16 plus 6. This is going to give us an answer of 60. And to find a median, I'm going to create a new column called CF, cumulative frequency. This helps me out over here. Let's keep adding the ones on the last column. So 8, this would be 20. We get 20 by doing obviously 8 plus 12. We keep adding on 20 plus 18 over here. 38, 38 plus 16, 54, 54 plus 6, 60. Snap. 60 should always match that 60 over here. Now, n divided by 2, this is where you have to understand this. N, median is n divided by 2 value. N is going to be 60 in this case, therefore 60 divided by 2 is the 30th value. You want the 30th value over here, the 30th value. Now the 30th value lies where on the cumulative frequency column. This is why we drew the frequency column over here, because the 30th value would lie somewhere between 65 and 70. See, the 20th person lies, let's say, right at the end of 65. The 21st person would lie at the beginning of 65. We want basically the 30th person. It's easy to understand it like this. So if you were to imagine this is your interval from 20 to 38, you want this one over here around 30. You want 30 over here, the relative proportion within this class interval. Now hold on to this thought over here. Let's understand this. This is what you want. It's the relative proportion within this class interval over here, and this is going to be defined as 10. So there are two aspects to this. The first thing is to find what class interval this would be. Number 30, the 30th person, would lie within this class interval over here, okay? And the lower bound of this would be 65. That's our first step over here. The second step is the relative proportion bit over here. So this is the lower bound. This is relative proportion. Now we are at 10 within this class interval over here. 10 over 18. We get 18 because this is the whole thing. 10 over 18, if that makes sense. The whole thing is 18 over there. That's the relative proportion within this group. It comes to about 5, because 5 is the class interval between 65 and 70. So we had an answer of 65 plus, let's say, 2.7 recurring. The answer will be 67.7 recurring. That's what the answer would be for the median.